Today we're going to investigate collisions between two objects on an air table. So like an air hockey table and slightly different types of pucks, which means that the surface is frictionless as the pucks move. But first we're going to start with one-dimensional collisions, and the image there of a puck, there are going to be two pucks and both are on the same frictionless surface. So the objects here are going to be pushed together simultaneously and along the dotted line so that it's going to be a direct hit. So two different people will give the puck just a sharp push simultaneously and to hit the pucks in the center of the facing sides. So pause the video and predict what's going to happen to both objects after the direct hit. So each rebounds and in the opposite direction to the initial push. So we are having momentum being mass times the velocity being conserved, and you can look at the equations there for initially and finally. And for an elastic collision, kinetic energy is also conserved. Half mv squared for each of the pucks. Initially you've got two pucks and finally you've got the same two pucks, and if their final velocity is the same, then we have conservation. For a one-dimensional collision, and looking at the diagrams here, going to be pushed together and then they're going to rebound. But we're here to look at collisions where objects don't stay in a straight line because of the way that the push occurs. And here's two objects on an air table. So one puck is going to be pushed to collide with a stationary puck, but it's going to hit the stationary puck off center. And both pucks are on a smooth surface, and here the object on the right hand side is going to be pushed off center to hit the second puck, and you've got the initial speed of the stationary being 0, and the right hand puck will be given a velocity. So again, pause and predict what's going to happen with an off-center collision. Each puck is deflected but not aligned with the direction of the push. So object 2 gets hit, and the action of hitting the second puck makes the original puck to be moved off its original course. So this one is a two-dimensional collision. When the objects are aligned and both pushed together, that is a one-dimensional.
It moves it around, but we're going to try to make sure that's as still as possible. You're going to take the other one in your hand. Don't hold it at the top. Hold it at the bottom. And you don't want it in your hand for a long time. You just want to go, and you want it to hit this one, but you don't want to hit it straight. So you want to hit it like you're playing billiards. You want to hit it off to the side so it goes like that. And then you know how it works. It makes all the dots, right? So we're going to see the dots. You're going to flip it over. You'll see the dots before the collision, and then you'll see two sets of dots after the collision. So you're going to get momentum before the collision, momentum after the collision. This one's, it's going to make 50 dots per second today. So you're going to see a lot of dots. You don't want to, so you don't have to push it fast, and you don't want to push it fast, so they move. But if you do it too fast, you don't get enough dots. So just, you're going to practice once, so you can see how it hits, and then you do it for, so I'll press the plunger, and you do it for real. Kick it over, and there you go. So you got. So don't use the first one, just skip. And all you need, it should be constant speed, so they should be relatively equally spaced. So just pick a bunch of dots. You get the distance, and then you can get the time, because it's 50 dots per second. Same with this one, and then same with this one. And then again, here, that's when it was in my hand. So just ignore the ones when it was in your hand. So don't use the very beginning ones. Don't use the absolute last one. They're equal. So both discs have the same mass. Okay, that's good. That is a good one.
Okay. You're going to press it when I press it?
Yeah, you're going to practice first.
Okay.
That's perfect. Yeah, if you can do that again. That's good. Yeah, that's good. You're going to ignore all that.
Okay.
That's before.
Like start.
That's after.
Almost like here.
Yep. Oh, perfect. Okay. That's a good one. Yep, there you go. There's not a lot before, but that's enough.
Okay.
So that's before, that's after, that's after.
And many thanks to Team Science at Washington International School with Mr. Jollymore and Mr. Godwin's IB Physics classes.